Hello guys, and welcome back to our YouTube channel. So in this video, I'd like us to really go detailedly about differentiation. I will use basically these examples, and the second part, if there's enough time, we'll still do it. So let us begin with the first part. That tells us that we should differentiate with respect to x, and a y equals to the ln of 1 minus x squared on e to the negative 2x, and b equals to y equals to cos squared root 3x. So let me begin with the b part before we then move to the a part. Okay, now we are saying that for the b part, y equals cos squared the square root of 3x. So now this one simply means that you should find the cos of 3x, then you square it. That is the meaning of this. If it was cos 30, you will then find cos 30, then you square it. It was sine cos something. That is just the general form of that. So to find this, I would really like you to take it step by step. So what I will do here is that I will say let p equals to the cos of the square root of 3x. Then which now implies that my y will simply be what? P squared. I'll just replace all this with p. I'll just get my p squared. Now to find dy dp, dy with dp will be simply 2p. By the way, if you are differentiating x to the power n, it is always n x to the n minus 1. So our n here is simply 2. So we'll bring down the 2 here, then we subtract 1 here. So we'll now just get p to the power 2 minus 1, which is simply p to the power 1, or p. Now if you have that your dy dp, now you go move now and say that if your p equals cos square root of 3x, to differentiate it again, we can differentiate cos x but not cos 3x. So I would say that let u equals to the square root of 3x. Now my p will be equals to cos u. I will also find dp du will be what? The derivative of cos u will be negative sine u. By the way, all the derivative of trigonometric functions that begin with c is always negative. So we get negative sine u. Now, I will now be having that if my u is equals to square root of 3, all that x, then du on dx will now be equals to the derivative of all of this. This one, well, let me first rewrite it a little. So we have u to be equals to the square root of 3 times the square root of x. This is the meaning. And I can have this to be square root of 3 times x to the power a half. Square root means to the power a half. And when I'm differentiating now this du on dx, it will be square root of 3. I'll bring down my power of x, which is a half. Then I'll subtract the power by 1. Let me see, half minus 1. 1 can be 2 on 2. This will be negative a half. So we'll be having negative a half as our power. So we'll now be having square root of 3 on 2 x to the power negative a half, which is same as square root on 3 onto all that on square root of x. Negative a half means x to the power positive a half down, and power half down can be square root of x. Now we get that. Now the next thing you do is simply to combine all what we have, all our derivatives, to get the derivative of y with respect to x. So now we'll be having dy on dx to be equals to, how are we going to combine it now? That is the question. We first found dy on dp. That is the first point where we differentiated here. We had dy on dp. That was the first thing we differentiated. Then the next thing we differentiated was dp du. So I will now multiply this by dp du. Then the next thing I found was du dx. I found du on dx. Please see a certain nice pattern here. Let me use a green ink to show that. So look at this. We are having p here, dp dp. We are having here du du. It is as if it will cancel, but don't cancel it, right? It is as if it will cancel, and then we are having our dy on dx here. So this is what we call the chain rule. These are just chains. They have just changed. We can still continue and find maybe ds on du, dus will cancel, and so on and so forth. We can still continue and continue with the chain. We can be finding maybe dx on maybe dt. You see, we've now been having, and it is cancelling and going. That's what we call chain rule. So if we combine this, we started with dy dp. Dy dp was simply what? Dy dp, we had 2p. So dy dp, we had 2p. Let me use white ink. Please don't wash with eye care. My phone is already eye care for you. I'm using the black ink. I also know about your eye defections. So we have 2p. My dy dp is simply 2p. Then my dp du. dp du is simply negative sin u. So I'll put negative sin u. Let me put that negative with red pen. Very, very technical to forget. Okay, dp du. Then we move to du dx. Du dx, we got it to be square root of 3 all on 2 the square root of x. Get by my white ink. So we got the square root of 3 all on 2 the square root of x. But now we started with x's. We have to end with x's, right? So you have to replace your p in terms of x. But what did we say p is? P is cos 3, cos the square root of 3. So we're having 2 cos the square root of 3x. Put bracket. Okay, we had that. Then we now move to sin u. So by the negative the sign of what was our u, we'll then replace it inside. Our u was simply square root of 3x. So we're having the square root of 3x, and we then multiply with our, what's happening, we then multiply with our dp du, which is the square root of 3 all on 2 the square root of x. I think that this is all your derivative. Don't cancel any longer. So we can cancel with these 2 here. These 2 can cancel, and this our negative sign can come out. So we'll be having negative sign. You can first write the negative 3x cos of the square root of 3x. I can also take this root 3 in front of it here. So this is now our derivative with respect to x. I think you have seen the concept. Anyway, this video is already lengthy. I will do the second part in the next video. Thanks for watching. If you find this video helpful, please just give us a like into this YouTube channel, subscribe to the YouTube channel, and share to all your friends. Thanks for watching once more.